It's out and out delicate, and it will detonate. No, giving me won't be an important opportunity to go for that. The thing is, it very well may be tomorrow, it may be during this transmission, and it would gleam like an ensuing sun over the James Webb Telescope. It has actually distinguished an unexpected 250% improvement in the splendor of Betelgeuse, the red star located at the shoulder of the Orion star gathering. This whimsical way to deal with acting has lit energy for a charming exhibit. Some suggest the flood in quality could show Betelgeuse is preparing to go supernova, yet the specific time remains sketchy. Specialists estimate it could happen soon. Join us as we explore the depths of space and relax the favored experiences, including this grand Goliath, scarab juice, which can potentially reshape how we fathom the universe. No matter what its name not being notable, you've probably appreciated its magnificence, a wonderful bronze shimmer sparkling brilliantly at the shoulder of Orion. A remarkable star gathering, Scarab Juice's monstrosity is wavering. When set at the center of our planetary system, its outer surface would extend past Jupiter's orbit. This monster star, easily perceptible, continues to charm us. Dissimilar to most stars, Betelgeuse changes clearly over time due to its nearness to our system. Named a semi-regular variable star, its splendor vacillates reliably, pushing toward a normal ideal breakdown in a vast blast. Recently, Betelgeuse has become substantially more stunning due to shocking changes in brightness. These changes include an immense flood on May 20, 2023. Researchers, puzzled, saw a floundering 142% increase in brightness, followed by a later update showing a 150% addition. As astrophysicist from the Harvard-Smithsonian Center for Astrophysics, Dupree, noted, Betelgeuse currently ranks as the 7th most brilliant star in the night sky, climbing 3 spots from its normal 10th position. From the southern part of the globe, Betelgeuse shines brightly at the night sky, easily observable at the shoulder of the Orion star cluster. Dr. Sarah Webb, an astrophysicist from Swinburne University of Technology in Australia, highlights Betelgeuse's significance. It offers a fascinating opportunity to study the last phases of a massive star's life, providing critical insights into red giants right before they explode as supernovae. When Betelgeuse eventually detonates, it could become extraordinarily bright for around 7 days, possibly casting shadows around nighttime. This prospect has both amateur stargazers and expert space specialists eagerly anticipating the event. Heidi Morris, a researcher at Los Alamos National Laboratory and president of the PD Stargazers and Astronomy Club, notes the persisting interest in Betelgeuse's brilliance contrasts with a phenomenon observed for a long time by various civilizations. Right now, Betelgeuse's bright cycle persists for only about 130 days, significantly shorter than its typical long-term cycle. These rapid changes offer astronomers a unique chance to focus on this heavenly quirk, comprehensively revealing insights into the last stages of a star's life. The astounding way Betelgeuse is acting began in 2019 when it violently shot out a piece of its outer atmosphere. These fluctuations in brightness are rare for Betelgeuse, raising questions about whether it will detonate into an infinite explosion, as demonstrated by a paper created by Dupree and other researchers from Harvard and the University of California, Berkeley. It will take another 5 to 10 years before Betelgeuse returns to its normal 400-day brightness cycle. Since the cutoff darkening, Betelgeuse has shown modified behavior concerning its light and rotational velocity, not persevering through its unusual lead. Betelgeuse remains a gigantic red supergiant star going through the last stages of rapid evolution as it depletes its fuel. The core will fall under immense mass, resulting in an enormous explosion that could cloud entire galaxies. The timing of this effect is problematic, as noted by Dr. Pierre, a professor of cosmology at the University of Portsmouth. Predicting large-scale explosion events remains challenging, given the limited historical data and the complexity of stellar evolution. Betelgeuse is currently going through fusion processes, continually generating elements like helium, carbon, oxygen, silicon, and iron. As a red giant star, it fuses helium into carbon at its core, a cycle that takes years. Eventually, it will advance to fuse heavier elements until it can no longer support fusion reactions, leading to gravitational collapse and potentially forming a black hole or a neutron star. While some speculate about Betelgeuse's impending impact, historical records show it has been growing redder over the past years, suggesting it may take a long time before it goes supernova. NASA estimates that Betelgeuse shouldn't explode for another 100,000 years, offering comfort that its explosion is unlikely to occur within our lifetimes. Despite the uncertainty, Betelgeuse's behavior. continues to captivate experts, and advancements in our understanding of stellar evolution are ongoing. Dr. Sarah Webb reminds us to stay open to potential outcomes, even as we acknowledge the improbable likelihood of witnessing Betelgeuse's explosion in our lives. Staying mindful of its movements might lead to further scientific breakthroughs, reminding us to keep hope alive for new discoveries in the universe. It's crucial to understand that our observations of Betelgeuse are essentially snapshots of the past. The light we see from the star is over 600 years old. Speculatively, Betelgeuse could have already exploded, and we wouldn't yet know about it. While this possibility exists, it is far from certain. History has shown us that our assumptions in astronomy can be proven wrong. Before 1987, astronomers believed only red supergiants could go through supernovae. However, that year, a giant blue star in another galaxy exploded, shocking the academic community. There is still much to learn, and surprises may lie ahead. Observing Betelgeuse and other massive stars allows us to expand our understanding of stellar anomalies. Regardless of the lack of an imminent explosion, Betelgeuse's current behavior is captivating. Its fluctuations between dimming and brightening reveal fascinating physics, and the fact that stars pulsate on human timescales is remarkable. While Betelgeuse is currently much brighter than expected, considering its usual long-term cycle, there's hope it will eventually return to this cycle. However, it is struggling to do so. Later observations have suggested that Betelgeuse may be in its final stage or nearing the end of its carbon-burning core cycle. This stage involves the transformation of carbon into heavier elements like oxygen and magnesium. If this is indeed the case, scientists predict a core collapse leading to a cosmic explosion that could happen within a few hundred years. However, the exact timing of Betelgeuse's evolution remains hard to determine, and uncertainties persist. The possibility of witnessing Betelgeuse's explosion remains unclear, as the carbon-burning phase can last up to 1,000 years, and the study proposing an impending explosion has not yet been accepted for publication. Nevertheless, the potential for Betelgeuse to become a supernova is exciting. It would be an unprecedented event, visible even during the day for several days. When the event occurs, the initial signs of the supernova's arrival will be subtle but clear, with neutrinos passing through Earth as high-energy photons escape from the expanding cloud of cosmic debris. Betelgeuse will gradually become brighter in the night sky, potentially reaching peak brightness 10,000 to 100,000 times its normal luminosity within just a few weeks. This spectacle will astound anyone fortunate enough to witness it, marking a crucial moment in cosmic history. The remnants of Betelgeuse's explosion could be as bright as a quarter or half of a full moon, appearing as a single point of light. Remarkably, this brilliance would be visible during daylight, casting dramatic shadows at night. Predictions suggest it could be 15 to 100 times brighter than Venus, currently the second brightest object in the night sky. The display of Betelgeuse's explosion would last in our view for about 100 days, captivating stargazing enthusiasts and providing a unique opportunity to observe the aftermath up close. Fortunately, Betelgeuse's supernova wouldn't pose any threat to humanity, as it is still far enough away. Telescopes and optics would allow us to observe the event for an extended period without harm. However, such a dramatic event would not go unnoticed. Supernovae were often interpreted as ominous signs, and Betelgeuse's destruction could spark intriguing reactions worldwide. Cosmologists believe it might even reignite widespread interest in astronomy, awakening people from their ignorance on a global scale. Betelgeuse isn't the only red supergiant in our system. Others, like Edi Carni, could explode before it does. In fact, our Milky Way should experience a supernova roughly once every 100 years, but we haven't seen one in the past 400 years. In reality, we've observed the remnants of past explosions, indicating we are overdue for a significant cosmic event. It's only a matter of time before the next star puts on its grand show for the universe to witness. Betelgeuse's history is rich with significant events, including the dramatic dimming in the fall of 2019. This sudden decrease in brightness stunned astronomers and ignited speculation about its potential explosion. Although Betelgeuse's brightness returned to normal by April 2020, the cause of its dimming remained a mystery until further observations shed light on the phenomenon. Skywatchers can easily identify Betelgeuse due to its distinctive location in the night sky. Betelgeuse's behavior continues to fascinate astronomers, as it remains a key object of study in understanding the life cycles of massive stars. Its fluctuations, particularly the significant changes in brightness, provide critical data that may help predict future supernova events. The star's unique behavior offers scientists a rare opportunity to observe the late stages of a red supergiant's life cycle, especially as it nears the end of its fusion processes. The more we observe Betelgeuse, the clearer it becomes that our understanding of stellar evolution is still in its early stages. Each new discovery about Betelgeuse and similar stars contributes to a growing body of knowledge that will eventually allow us to better predict the life cycles of other stars. While the exact timing of Betelgeuse's eventual supernova remains uncertain, the interest in this star continues to be a driving force in astronomical research. In the years to come, as we gather more data and refine our models of stellar evolution, Betelgeuse will undoubtedly remain a focal point for astronomers worldwide. Whether or not we will witness its explosion firsthand, the lessons learned from studying Betelgeuse will continue to shape our understanding of the universe. As we wait for more observations and breakthroughs in the field of astronomy, the story of Betelgeuse serves as a reminder of the vastness and mystery of the cosmos. It reminds us that, while we may have advanced in our understanding of the universe, there is still so much more to learn. The future of space exploration and astronomical discovery holds endless possibilities, and Betelgeuse will likely remain an enduring symbol of the ever-unfolding mystery of the stars. As astronomers and scientists continue to monitor Betelgeuse, their work highlights the dynamic and ever-changing nature of the universe. Each observation of Betelgeuse not only helps to uncover the secrets of this particular star, but also provides valuable insight into the broader processes that govern stellar evolution and the life cycle of massive stars. The data gathered from this star will be instrumental in advancing the fields of astrophysics and cosmology. Looking ahead, the possibility of Betelgeuse's explosion, when it occurs, will be an event of immense significance, not only for astronomers, but for humanity as a whole. It will be a celestial occurrence that transcends scientific interest, captivating the imagination of people around the world and sparking a renewed sense of wonder and curiosity about the cosmos. The study of Betelgeuse and other supergiant stars could lead to groundbreaking discoveries about the formation of galaxies, the creation of heavy elements, and the ultimate fate of stars. In the meantime, astronomers will continue to refine their models, relying on both current observations and historical data. Each new technological advancement, whether in observational instruments, computational simulations, or our understanding of cosmic processes, will bring us closer to unraveling the mysteries of these massive stars. While Betelgeuse may not explode in our lifetimes, the legacy of its study will persist. The insights gained from this star will guide future generations of scientists and shape the direction of space exploration and astronomical research. It's a reminder that the pursuit of knowledge is an ongoing journey, one that spans generations and continues to illuminate the vast expanse of the universe. Ultimately, the story of Betelgeuse represents a powerful reminder of the impermanence of stars, and by extension, the fragility of life itself. As we observe and study these cosmic giants, we are reminded of the cycles of birth, life, and death that govern not only the stars but our own place in the universe. The explosion of Betelgeuse, when it finally happens, will be a reminder of the immense forces at work in the universe, and how even the brightest lights can fade into darkness, only to be replaced by new stars, new discoveries, and new chapters in the never-ending story of the cosmos.